Hi everyone, my name is Will and I'm going to be going through some past WJEC exam style questions, part of the 2.4 chemical reactions and energy segment. So for the first question, we need to somehow raise the temperature from 50 degrees to 70 degrees. So we need to think of a way of releasing more energy into the food. We can do this by using more calcium oxide. So the more calcium oxide you use, the more heat energy will be released to the food. So more energy would be released from the calcium oxide, which would heat up the food. You could also say that you can use smaller particles of calcium oxide, and this would result in a quicker reaction. You can also think about it as in terms of the water, so there could be less water in the can, or thinking about thinner walls on the can. For question B, you'd have to think about this question in terms of bond breaking and bond forming. So I always like to start with a simple definition. So for an exothermic reaction, energy is released to the surroundings. Then from this you can tie in what an endothermic reaction is, then talk about it in terms of bond breaking and bond forming. So for the first mark you would have to say bond making releases energy and bond breaking absorbs energy. So for you have to think about it when it comes to these questions, as you might get them the wrong way round. So in order to break a bond, energy needs to go into it. So for example, if you have an elastic band, you need to put energy into the elastic band in order to break it. And then for the second mark, you say reactions are exothermic because more energy is released than it is absorbed. But normally with these questions, I like to round up with a little conclusion sentence. So you can say, therefore, there are more bonds formed than being broken. For question 2, you would have needed to have plotted a graph of volume of acid added against temperature. So I use Microsoft Excel, but in an exam, you'll get some graph paper or there'll be some graph looking paper inside the exam paper. So you should get a graph like this. So on the x-axis, you'd have volume of acid added, and on the y-axis, you'd have temperature. So you needed to plot a line of best fit, but as you can see here, the line of best fit needed to have been curved, not a straight line. But if you did use a straight line, you would have got follow-through marks. So let's answer 2b. So for 2br, you would have to have got the maximum temperature rise during the experiment. So we would need to have found the highest and lowest temperature. So as you can see here from our table, you can see the highest temperature was 26.5 and the lowest temperature was 21 degrees. So if you do 26.5 minus 21, that is 5.5 degrees C. And from part II, you'll need to find the volume of acid added to neutralise all the alkali. So from the graph here, we have to find the place where the curve is 0, so where it's not going up, it's not going down, so it's flat. So as you can see our arrow here going across, as you can see it goes flat, then go down, and you can see that the amount of acid added was about 50 centimetre cubed, but it's a bit leeway depending on your graph you've drawn. So for 3C, we need to have looked at how to reduce heat loss within the experiment. So I put the diagram on the left here. So a clear thing you should see is that the polystyrene cup is a method to reduce heat loss. And you can also see here, if this was repeated, how would we reduce heat loss even further? From the diagram, it should stand out that it needs to be a lid, because heat can escape through the top, it just doesn't escape through the sides. Or another way you could do is add the acid quickly. And for question 2D, you need to find a word that best describes this reaction. So from the 4 words, combustion, exothermic, endothermic, and oxidation, it's best to write their definitions and see which one fits. So a combustion reaction are reactions with oxygen from the air. Exothermic reactions are when energy is released to the surroundings. Endothermic reactions are when energy is absorbed from the surroundings. And an oxidation reaction is when oxygen is added or there is a loss of electrons. So as you can see here from the graph, you can see that energy is released, so therefore this had to have been an exothermic reaction. So for question 3a, we need to balance the combustion equation for propane. But for combustion equations, I always like to give a few tips. So first of all, I always balance the number of carbons, and then balance the number of hydrogens, and then I balance the number of oxygens. So here is the equation for propane, and we need to balance it. So every time I like to balance equations, I always like to assign little symbols to each of the atoms on the product and the reactants. So therefore I can count them at the end to make sure I've got them right. So there are crosses for the carbons, circles for the hydrogens, and dashes for the oxygens. And I do this the same for the products as well. So as you can see here, I balance the carbons first. So there are 3 on the left, therefore there needs to be 3 on the right. Therefore, we've multiplied CO2 by 3. Because the carbons are multiplied by 3, we need to multiply the oxygens by 3 as well. So 2 times 3 equals 6. Now we look at the number of hydrogens. There are 8 on the left and 8 on the right. Therefore, we don't need to balance them at all. Then finally, we need to balance the number of oxygens. So on the right-hand side, we have 10 oxygens. And on the left-hand side, we have 2. Therefore, we need to multiply the O2 by 5 to get 10 oxygens. Therefore, the final equation is C3H8 plus 5O2 goes to 3CO2 plus 4H2O. So for question 3b, we need to look at the equation in the question. So on the reactants, there were 2 hydrogen molecules plus O2 goes to 2 water molecules. So question I was about calculating the energy produced when all the bonds in the product are made. So in the product, we have 2 water molecules, and as a result, we have 4 OH bonds. A single OH bond corresponds to 463 kilojoules. Therefore, 4 times 463 is 1,852 kilojoules, and that corresponds to the energy produced when all the bonds are formed in the product. Then for question I, we need to use the information to explain why the overall reaction is exothermic. So the energy change is the energy of reactants minus the energy of the product. So the energy of the reactant was 1,367 kilojoules, and that was stated in the question, and the energy of the product was 1,852 kilojoules, which it just previously worked out. And this equals negative 465 kilojoules. As you can see here, it's a negative value, and negative values means exothermic reactions. And every time you say exothermic reactions, you should always say this means that more energy is released than taken in. Question 4 is kind of exactly the same as the last question, but with a different reaction. So question AI was about finding the relative energy needed to break all the bonds in the reactants. So for this, I always like to make a table. So in the reactants, you can see we have 1 hydrogen-hydrogen bond and 1 chlorine-chlorine bond. So if you add these up, so 436 plus 242, this gives us an energy of 678 kilojoules needed to break all the bonds in the reactants. For question II, we do the same, but I need to do the ones for the products. So as you can see from the products, we only have a hydrogen-chlorine bond, but we have 2 of them. Therefore, the energy from this is 862 kilojoules. Therefore, for part B, and using our answers from part A, we need to state whether the reaction between hydrogen and chlorine is exothermic or endothermic, and given a reason for this answer. So first of all, let's find the energy difference. So the energy of the reactants minus the energy of the product. Therefore, 678 kilojoules minus 863 kilojoules equals negative 184 kilojoules. As you can see, it's a negative value. Therefore, more energy is released than absorbed. Therefore, overall, this is an exothermic reaction. For question 5AI, we need to use this table and suggest conditions in order to maximise this process. So every time we do a chemical reaction, we always want to maximise the yield. So as you can see from the table, the maximum yield is 99.9%. So as you can see, this is in the 100 degrees column for temperature and in the 1,000 atmospheres column for pressure. So therefore the answer for pressure would be 1,000 and the answer for temperature would be 100. 5AII, we need to give a disadvantage of using low temperatures and suggest how this is overcome. So every time we think about low temperatures, we need to think about the rate of reaction. So by using low temperatures, this means there'll be a slower rate of reaction. And normally, in order to speed up rate of reactions, we include catalysts. So therefore, the answer for this is for 1 mark. So if you say a slow reaction, for the other mark, you have to say a catalyst is used as this would speed up the rate of reaction. So for 5AII, we need to suggest a disadvantage for using high pressures, which isn't a safety issue. So normally when you use more pressure, that means more energy, more electricity is used, therefore this always means higher costs. But also you can say that when you use greater energy consumption, this could lead to greater fossil fuels being released into the atmosphere. So question B is all about ammonia and the nitric acid formed within the step process within the exam paper. So for question I, we need to state the term needed when there is sufficient heat, and we should all know this is a combustion reaction. For question BII, we need to balance the following equation in step 3. So here's the following equation from step 3, and usually I like to symbol everything. So first of all, I needed to balance the number of hydrogens. So there's 4 on the left and only 1 on the right. Therefore, I need to have multiplied the nitric acid by 4. And then finally, I would need to balance the number of nitrogens. So now there would have been 4 on the right. Therefore, now there'll be 4 on the left. Therefore, the overall equation would be 4NO2 plus O2 plus 2H2O goes to 4HNO3. And finally, for the final question, we need to write a balanced symbol equation for the reaction that occurs when nitric acid is added to copper 2 carbonate. So first, let's split up and see what copper carbonate is and nitric acid. So copper 2 is copper 2 plus, and carbonate ions are CO3 2 minus. As you can see, we can combine them together to get CuCO3. We did not have to add any more coppers or any more carbonates. As you can see, the charge is balanced. Therefore, nitric acid is given as HNO3. Therefore, the nitrate ion is NO3 minus. Normally, for a reaction, when you add acid and carbonate, it releases a salt, water, and carbon dioxide. Therefore, we have the acid, which is nitric acid, and the carbonate, which is copper carbonate. This will form copper nitrate plus water plus CO2. So you think you would finish here, but no, you need to balance the equation. So do all the things that I've done before, put little symbols and stuff like that, and you all have to. And the only thing you have to balance are the hydrogens. So as you can see, there's 2 on the right in the water and only 1 on the left. Therefore, we need 2 nitric acids for this reaction to occur. So the final equation symbol is copper carbonate plus 2 nitric acid goes to copper nitrate plus water plus carbon dioxide. Thank you for listening.